it's the slope-intercept form, because this is the 0, comma a number. So this is a nice situation in which we replace the slope by -1/2, and B is 4/5. Is it wrong to use y minus y1 equals the slope times x minus x1? No, it's perfect, but it's more work, a little bit. We have this equation that is directly, it gives us directly the equation of the line with the slope that is given to us and the y-intercept.
I didn't realize.
Yes, yes, that's fine. That's why I'm here. So please remember, you should always look at the point. If the point is a weird point, then you have no choice. But if the point is the nicest one, 0, comma, you should always think in these terms. And you can say this is useless because this is valid only in this case. I understand. And some students say to me, I never even bother with this one. I always use this. Fine. That's fine. Whatever works.
Use both.
Yep. This has limited applicability, only in this situation. This one can be applied for any point, including this one. So it's up to you. Mortez, is this okay? Good. Anything else you'd like to work on? Anything else you'd like to work on?
I'll share my screen.
Yes, please. You have permission.
Professor Lee,
Yes.
I'm gonna get in my car and head to the urgent care. I just want to let you know in case I lose reception because I'm gonna use my phone to get me Wi-Fi.
Okay. I hope you feel better. You can watch the video. I'll post it after class.
Can I share my screen now?
Yes, yes, yes.
Okay. Can you see it?
Almost. Good. Okay. So list 3 techniques that can be used to graph a line. Using slope and the point. Yes. Using slope only, that's not possible. Using both intercepts, of course. Yeah. Using only the y-intercept, no. Using at least 2 points on the line, yes. Using only the x-intercept, no. Using a single point on the line, no. Find the slope and y-intercept of the line. Good. The y-intercept is right there. You can see it, you can read it. The y-intercept of the line. So type an ordered pair. Careful, careful. The y-intercept. Yep, I've done that too. I've done that too. Read the fine print. Yes.
Right.
Now you have to determine the slope. You can determine it from the graph, finding the rise and the run, or identifying the 2 points and using the formula, whichever works. Careful. Yes, yes.
Okay.
Find the slope and the y-intercept. As you see, the y-intercept and the x-intercept are the same point. So then this line definitely will not have a free term
Okay.
when you get the chance to write the equation. So the x and the y-intercept, so it says the order that, yes, they are the same point. And I have to be careful. Yes, exactly. Good. So this is a simple situation because the given point is what?
0, -1.
Exactly. So you have a simple equation to use straightforwardly.
What is it? I'm sorry.
Say it again.
Sorry, I'm confused.
You got x equals 0, so you have the x-intercept already.
Right. So we have to write y equals.
Right.
You have to write 4x minus 1 because it's y equals mx plus b.
Oh, okay. I got it now.
So that is the easiest equation when we are given the y-intercept. This easier equation to work with.
Is that right? Or,
The same thing, very easy, because the equation is mx plus b, and we are given the y-intercept. Exactly. So, so the equation of the line whose slope is -1 and y-intercept is, oh, you forgot to write the x, yeah.
yeah.
Good.
This one always messes me up. I don't remember if it's horizontal or vertical.
Right. You probably missed that class. So when we talk about y equals is always altitude. Always
that?
altitude. You go up or down in altitude. That's y. The location or position is always x equals. X equals is always location or position.
Like that?
Say it again.
No, I got it.
So a quantity is initially this and decreases at a rate of 8. So if it decreases, it means that the slope, yes, it means that the slope is negative. What is the equation? Yep.
Sorry. Oh my lord. It's like,
So use the sliders for y1 to create the graph of y1 equals to 8. Okay. So if you want to stop just sharing for a second, I want to explain something here.
alright.
So parallel lines have the same slope. So this is M1 and this is M2. They are parallel because the slopes are equal. Or if they are equal, they are parallel. So parallel lines. So if we have, for example, 2 points. Let's say I have this point and I have this point. and I want to graph through both points, not the same line. I like to graph two lines that are parallel. I will graph this, but I have to be given the slope, whatever it is. Or I can graph this. So two lines that are parallel to each other. So that's what they're saying by sliding this further to the left or to the right, or slide it to the left and right, or up and down. So this line, for example, and this line are parallel. They have the same slope, and they pass through different points. Does it make sense?
Yeah, so you just have to have the same slope.
But the slope has to be given to us.
Yeah. Okay.
And then we will graph lines that are parallel. I can graph vertical lines that are parallel too. So, for example, these two are parallel. I can graph horizontal lines that are parallel as well.
Okay.
Does that work?
I got it.
Okay. Two lines have
Share
this-
my screen.
Yes. Yeah. Once I give permission, you can continue. Sure. I don't think I even need permission to share. I think it works without. Good. So use the sliders for y1 to create a graph of. Okay. Now use the sliders for y2 to find the equation of the line that is perpendicular to. Okay, that's a different story. The perpendicular situation. So let me explain the perpendicular. We had that last time, but we didn't get the chance to work on an example. So if you want to stop sharing for a second. Okay, so two lines are parallel. So we have this in the notes, but I put them away. So two lines are parallel if they have the same slope. Now, if I have a line and I'm given, let's say the slope is 1/2, and I am told what is the slope of a line that is perpendicular to it. In other words, they form four 90-degree angles. So this is the slope m1. Then the slope m2 will be the negative multiplicative inverse. So this will be -2. So if two lines are perpendicular, the product of the slopes is -1. The product of the slopes is -1 if two lines are perpendicular to each other.
Okay.
So if I'm given, let's say, the line y equals 2/3 x minus 4, the slope here is 2/3, then this one has to be -3/2. So the other line will have -3/2 x plus whatever y-intercept. Because 2/3 times -3/2 will equal -1.
Okay.
So for parallel lines, that's easy. The two slopes are the same. But for perpendicular lines, it's a little bit different, more sophisticated if you want. The product has to equal -1. The product of these two slopes equals -1, so this line is perpendicular to this line. So these two lines, for example, are neither parallel nor perpendicular. So there is no relationship between m1 and m2. The slope of the first and the slope of the second. No relationship whatsoever. When they are parallel, the slopes are the same. When they are perpendicular, the product is -1. When they are neither nor, no relationship. Good.
Can I share my screen again?
Yes, 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 yes.
If Matthew leaves, he looks like he wants to leave.
He can leave. He's way ahead.
Okay.
I think he finished the course already or something.
Okay. I don't know if it's yes or no.
So let's take a look. The slope of the line y equals -2 is 0. And are the equations perpendicular or not? Let's go back up. So x equals 4 is a vertical line, is position, location. Y equals -2 is a horizontal line. They must be perpendicular. A horizontal
okay.
line and the vertical line must be perpendicular. There is no other way.
So
And you can say, well, this is a contradiction to what you said, because one of them has a slope undefined and the other one has 0. True. It's the only situation in which the product does not equal -1 and the lines are perpendicular. Because one of them has slope 0, the other one has slope undefined. But it does not contradict the general rule. Okay, for the given pair of equations, find the slopes and determine whether they are parallel, perpendicular, or not. So let's do this problem together. It's a very good one. Let's do this problem together. So let me copy it, 1 second. So we have 19x minus 3y equals 6, and the other one is 3x plus 19y equals 76. If you want to stop sharing for a second.
right.
In order to identify whether two lines are parallel or perpendicular, I have to find the slope. But in order to find slope, I have to solve for y. I can't find the slope if I don't solve for y. So the first equation, I move 19 wisely. 19x in front of 6. -3y equals -19x plus 6. I divide term by term by -3. So y equals 19/3 x minus 2. And I identified the slope. This is m1 equals 19/3. Now, if m2 is 19/3, they are parallel. If m2 is -3/19, then they are perpendicular. If none of the above, then they are neither parallel nor perpendicular. So I don't know. I have to find the slope. So 19y equals -3x plus 76. I divide both sides wisely, term by term by 19. I identify the slope m2, which is -3/19. And now I think, if they are equal, I'll say parallel. If they are multiplicative inverses, meaning if this product is -1, then they are parallel. If none of the above, then they are neither nor. So,
Okay, I got it.
they are what?
Perpendicular.
Yes, they are perpendicular because the slopes are not the same, so they cannot be parallel. And when you create the product, you get -1. So they must be perpendicular. Very good. Excellent.
I'll share my screen again. Hold on.
Of course. Yes, Sarah, you can.
Thank you.
Good. So the same thing. The same thing. We have to find the slope. We have to solve for y. Okay. You have to simplify it and negative 4/3. Good. Well done. The slope of a line parallel to the given line. So the slope of a given line is undefined. Wait. So the slope of a given line is undefined, which means it's vertical. Find the slope of a line parallel to the given line and the slope of a line perpendicular. Okay, so that is, no. You were correct. I was just reading the problem. Sorry. You were correct. It is indeed parallel to parallel lines. A parallel line to a vertical line has undefined. Slope undefined, yes. Yes,
Okay.
that is correct. I was just reading this, the slope of a perpendicular line. Yes. To the yes, to the one that has, yep. Good. Good. So it took you 5 minutes, 7 minutes.
This one. Oh. Wait.
You have to go through the practice of 4.4 before we move on to learn 4.5.
Hold on. This one. Guess I'll do this one.
Good.
This one.
Find the slope. Good. So it's rise over run. Yep. For every 3 unit change in x, the change in y is 1. Correct. Yep.